Awesome. Well, hi, everyone. Thank you so much for having me. I am not in my typical office today, and I sat down in front of this background, and I felt like this is where I'm meant to be at this moment. Just a mash of patterns going on. So hopefully no one is too upset by that. My name is Eve Porcello. I can be found on the internet at Eve Porcello. You can also follow along with the resources here. So if you go to, I'll put it in the Twitch, github.com/Eve Porcello/Reactadelphia. I am a teacher above all things, so I will force you, if you want, to type things along with me. If you don't want to, that's totally fine. I said force. I don't know why I said that, but you get the idea. If you want to follow along, you totally can. All right, so I'm coming to you live from Tahoe City, California right now. We work for Moon Highway. Moon Highway is a training company that teaches a lot of JavaScript. We also create courses for LinkedIn Learning and Egghead.io. And we wrote this book about GraphQL. And we just recently rewrote this book about React. So if you're looking to learn React, you can check out this book if you'd like to. Or I'm going to tell you a secret. You can DM me on Twitter and I am a pushover. So I will send you a free copy of the book because I'm bad at business. So feel free to send that request and I will be happy to fulfill it. All right. But I'm here today to talk to you about GraphQL subscriptions. GraphQL subscriptions are a very exciting thing. So let me first show you what a GraphQL subscription looks like simply by showing you this in action. So let me tell you a little story. One time I hosted a conference with my husband, Alex. We decided that we were going to have an election to decide who should be the host of the conference for real. So we put it up to a vote, a GraphQL vote to decide who should be able to be the host for the rest of the event. So we built this with GraphQL. And we built this using GraphQL subscriptions. So let me show you a little bit about what these GraphQL subscriptions look like over here in the GraphQL Playground. So if you haven't seen a screen that looks like this before, the GraphQL Playground is a interface that you can use to send GraphQL queries to your data. So you can actually follow along with this if you'd like to. Vote.moonhighway.com is where all of the voting will occur. Now, with GraphQL, there are 3 different types of operations that you can send to a GraphQL server. So the first of these is a query. So remember our React, it always looks really good when I zoom in. Remember our UI over here, we had Alex and Eve. If I go back to the playground, I can check out this data here. So I can send a query for results. And then what I want to look for is the results for Alex and the results for Eve. So right now it's 0, 0. So that's a query. That's how we get data with GraphQL. Now, we also can send mutations to a GraphQL server. A mutation is an operation, think of them like the verbs. How do you change data? Everything is going to happen with a GraphQL mutation. So we have here a mutation called vote. Now I'm going to send the name of the host, Alex, who I want to vote for. So I want to vote for Alex, and I'll send that a couple times. So if we look over here in the browser, we see that Alex is getting a lot of these votes. Every time this vote comes in, we are capturing it. Now, here's where things get interesting. There's a third type of GraphQL operation, and this is one that sometimes gets overlooked, but today is the day to make this type of operation a star. This is the GraphQL subscription. So if queries get data, mutations change data, subscriptions do something a little different. Subscriptions are going to listen for data changes in real time. So let's check this out. So the subscription, if we look at our documentation panel over here, there's a subscription here called result. So result is going to return an object with 2 keys. It has either Alex or Eve. So let's see what this looks like. So I'm going to send results, and then I will pull up Alex and Eve. Now this looks sort of similar to my query, pretty similar, right? But if I hit play on this subscription, notice that this is listening. So we got some listening going on. It's not the request and response that we saw with the query. Instead, we're listening for those changes in real time. So if I send a vote, if I send a few votes here, all of those are going to be captured. Those are going to be pushed back to our clients in real time. So this is pretty awesome. We're able to send a query to get some data. We're able to send a mutation to change some data. And then if we issue a subscription of any type like we have here, this is going to capture those results in real time. And the UI does so too. So if I refresh this and zoom it out a little bit, we see that as people are voting, this is going to happen in real time. So sometimes people will vote while I'm doing this, but I'm going to make it happen this way. I'll do some secret voting here. So let's vote for Alex a couple times and check it out. This page is listening. We're going to listen for those changes all the time. So that's vaguely exciting. That feels like something cool is happening, right? We're able to enable subscriptions using this setup and using this GraphQL server. All right, so let's take a step back and talk a little bit about where these GraphQL subscriptions come from. So GraphQL itself is just a spec. What's a spec? It's just this document that describes everything that's part of the language. So we have the query language, which we saw using the playground a second ago. That's the language that describes all the syntax for these queries, mutations, and subscriptions. So the subscription here is the third type of GraphQL operation. You can click on that link and read all about that if you want to. But I'm highlighting this important part, which is that subscriptions are actually part of the GraphQL spec. When we create a subscription, we write them directly into the schema. So the schema is this document that describes all of our API's different types. So let's say we have a photo sharing application and we're allowing people to upload photos. We can create a subscription for a new photo, and then I'm going to listen for any time a photo is uploaded. So that's what that looks like in the schema. GraphQL subscriptions were used first at Facebook, so they rolled them out in production for real for, first of all, live likes. So if you see like someone clicking on the like button, if there's a popular post, you see that happening in real time. All of that is powered by GraphQL subscriptions. Same with live likes, or not live likes, same with these live videos rather, where these little emoji bubbles are floating up and down on the screen. You may have seen something that looks like this. It's pretty cool. All of that is powered by GraphQL subscriptions. So another thing to know about these, Ticketmaster is using these a lot, even though Ticketmaster, like tickets and events, don't necessarily exist in the way that we thought they would. But when they're back and you're waiting on your concert tickets, all of that is going to be powered by GraphQL subscriptions as well. All right, so what I'd like to do is this. Over in our little repo here, github.com/Porcello/React-Adelphia, we have, if you want slides, my slides are not as cool as Emily's, obviously, because I lack the skills to design them properly, but they're there if you want them. We also have links to the voting application if you'd like to check that out. Nice hooking up the link in the chat. But what I'm going to look for here is the voting app. Let's see, what am I looking for? The voting app repo. So this is the actual hosting the election thing. So if you want to take a look at what this full app is, that Alex and Eve app, you can feel free to borrow from that and vote between two different things. But what I want to do is I want to go through kind of the process of building this. And we're going to do this using Apollo Server. So let's take a look. So our vote activity, right? My screen work is atrocious. I don't like what I'm doing. Let me get this back on the screen and slow down. So this vote activity, if you go to the main branch, you can see the start file. So that's just in the index.js here. And that's where I'm going to start. If you want to see where we're going, if you like spoiling the ending, you can look at the complete branch if you'd prefer. All right, so back to our code. This is our little starter project for setting up subscriptions with Apollo Server. On line 1 here, we have the server setup. On line 3, we're creating our schema. So remember, the schema is that document that lists all of your types. So you can think about what are the types that are part of your API? Are they photos? Are they, I don't know, products? Are they cars? Whatever. All of that's going to be defined in your schema. These resolver functions here are the functions that are going to return data for the schema. So in the schema, we have a query here called build. We say build should return a string. On line 11 here, this is where I actually do it. The build resolver is going to be called and it will return a string. So all of that matches up. So again, I'm using Apollo Server here, but I'm using one of the many different libraries out there that exist. So feel free to use whatever feels right to you. But because I have that defined in the schema, I can send a query for build and it'll tell me to build something cool. So I listen to instructions, so I'm going to do that. So what I want to do here is let's build our little voting application. Now, what I need from the chat is I need something to vote between. What do we want to vote between? Alex and Eve, those are just boring people. Let's vote for something actually cool. Like tabs and spaces, cats versus dogs, pizza versus tacos. I love these. People are on it. You all are on it so hardcore. Philadelphia versus everyone. All right, I have to do that one, I think. We got to go for it. Yeah, let's do it. So the next step is I need to create a little database in quotes of data. So let's do it up here on line 3. We're going to say let Philly, I'm going to make it shorter because I will spell it wrong, equals 0. No one knows that. I'm being honest though. And then we'll say let everyone equals 0. So that's the starting database. From here, what we want to do is we want to start to define what we want in our schema. So the first thing we want is some sort of capturing of results, right? So we're going to create a type called results. Remember, results was that little object that we got, Alex and Eve. This time, though, it should be Philly, which will be 0, or sorry, which will be an int. And then everyone, which will also be an int. Now, when I send that query for results, I don't want to return a string anymore. What I want to return is the results object. Cool. So now let's go ahead and change our resolver here. So here on line 18, I'm going to do just that. We're going to say results. And what results should return? Well, it should return an object with Philly and everyone. Cool. So far, so good. What else do we need to do? Let's test it so we make sure that things work, because we like it when things work. So Philly, everyone, I'll prettify that so that looks better. And we got it. We have Philly and we have everyone. So far, so good. Now, the next thing I need to do is I need to define my function, my mutation for voting. So what we'll do here is let's go ahead and create a type. And our type is going to be called vote. Now, every time someone votes, we need to accept an option of some sort. So let's just say option, and then we'll make the option that is passed. We'll call it, because I'm very creative, an option. And then what this should return is a string. So we'll say, now that we've created this option, we need to create what's called an enum, an enum, whatever everyone wants to call it. I'm not going to get too specific on that, but what I am going to do is I'm going to define the option between either Philly or everyone. So an enum type, think of it like a drop-down list of options. It's a restricted list of options for a particular field. And this needs to go away. Nice. Cool. So we'll say Philly and we'll say everyone. Awesome. So far, so good. So we have our mutation. We're going to pass it the correct option, and then it's going to return a string. So now that we've done this, what we want to do is we want to create the mutation in the resolvers. This is kind of that process of creating a GraphQL API. We create something in the schema, and then we build the functions that are going to take care of getting the data or changing the data in some way. So in our mutation, we're going to use vote. And in order to capture the option from the vote, I need to access the second argument here. So we're going to say parent args, and that's it for now. I'm not going to explain what parent and args, or I'm not going to explain what parent is because I will go over time and everyone will be upset, but I'll be happy to talk about that later. So we'll put a pin in this. What we should know about this args object is that args is going to help us to parse whatever the user puts in. So remember when I was voting for Alex, I was able to capture it by this function by passing it through this object. The next thing I want to do is let's go ahead and say const, we'll say increment equals 1. And then we'll say if args.option equals Philly. Then we want to say Philly plus equals the increment. Otherwise, we want to add to everyone. So again, we're just adding values to our tiny little database here. So we'll say else everyone plus equals that. Okay. I don't know what I'm trying to pull here. All right. Okay. So cool. So that's looking pretty decent. Let's go ahead and try this out. The last thing I need to do is because I'm returning a string here, I need to make sure that our function returns a string also. So let's go ahead and do that. So that looks better. I needed an arrow. Probably people are telling me that in the chat, but I'm not reading it right now because I know I'm going to run out of time. So I'm just going to roll. So I'll say thank you for voting. And I don't know what this was all about. There we go. Nice. We're not going to fall apart. We're going to stay calm. Awesome. So let's go ahead and try. So we're going to try this vote function out over here on localhost 4000, which is where the defaults will run. And we're going to say, and let me refresh this so we get the whole schema helping us out here. We're going to say option. And who should I vote for? That's my question. Who should I vote for?
I think you know there's only one real answer here.
Probably Philly, right? Okay.
That's probably good.
Awesome. So I'm going to hit play and it'll say, thank you for voting. So I have voted for Philly. Yeah, good choice, obviously. I'm going to go over here to the results and we'll try to query the data. And we see that we've voted for Philly 5 times. Pretty cool. I'm here to talk to you today about GraphQL subscriptions, though. Yeah, everyone get out of here. You lost. Philly's winning. So I'm here today, though, to talk about GraphQL subscriptions. So let's make sure that those work before we clear out of here today. Like a mutation or a query, we create a subscription simply by first adding it to the schema. So let's go ahead and create a type called subscription. And this is also going to return results. Cool. So it looks a whole lot like a query, but it's going to behave a little bit differently. Now, with Apollo Server, I'm going to set up my subscriptions to work. So I'm going to incorporate one other thing from Apollo Server, and that's PubSub. So PubSub is this engine that ships with Apollo Server that we can use for simple demos like this to make sure that our values, to make sure that everything is being captured correctly. So we're trying to make sure that we're keeping our database correct. So we're going to do that with PubSub. We'll show you in a second how that looks. But the first thing that we need to do is we need to create a new instance of it. So I'll say PubSub equals new PubSub. Sweet. Now, we have PubSub set up, sort of. We have our subscription created. The next thing we need to do, of course, is we need to create a resolver. So down here on line 43, I'm going to create my subscription resolver. The subscription resolver is going to be under this results key because that's what the subscription is called. And then because it's a subscription, it has this important function called subscribe, this important method called subscribe. Now, subscribe is going to, let's take a look at this. It's going to take in parent, args, and one other thing called context. And context is going to come from when we create this Apollo server. So that's looking pretty good. But I also need to make sure that we're setting context to equal PubSub. Sweet. So now what I can do on line 45 here is I can send in PubSub from context. So this is that engine that's going to make sure that it's capturing all of our votes correctly. Now, the reason that we're using PubSub here is because we're going to use this little function. It's called async iterator. Now, what the async iterator will do is picture yourselves, we're all using the same app together. The async iterator is going to go through all of the different devices or computers or whatever that are subscribed to this event, and it's going to listen for any votes. How are we going to publish the votes, though? Well, the way that we're going to publish these votes is actually with the mutation. So up here in our mutation, after we increment the values of Philly and everyone, of course, we're going to call PubSub.publish. We're also going to make sure to pass that in via context here. So pubsub.publish, we're going to say vote recorded. And then we're going to show Philly and everyone. So that's our little object that's going to be returned. We saw this with the Alex and Eve voting a little bit earlier, where we captured those values. Every time we sent a mutation, we were able to capture those. Cool. So that's a lot. But just to recap, we have created a subscription. We have created the subscription resolver. This subscription resolver is going to listen for any events. It's going to listen for any mutations that come through. So I guess we got to see if it works, right? And if it doesn't, we're not going to freak out. We might a little bit inside secretly. But our subscription is called results. We have Philly and we have everyone. Now, if we click play, we see that it's listening. That's a good sign. And now if we vote for Philly, the only possible option, that's going to capture those values. Pretty cool. So, like I said, all of the code is linked in that repo that I showed you before. I do want to show you one other slide. Basically, the way that these subscriptions are working with Apollo server is that queries are sent over HTTP. Mutations, same drill. They're sent over HTTP too. Or HTTP also. That sounds like a confusing way to say that. But subscriptions are sent over WebSockets. So that's the transport for this type of operation using a GraphQL server. So anytime you're thinking about incorporating some real-time data in your apps, you can use a GraphQL subscription to make that happen. And that's how it works. It's 100% working over WebSockets. So I'm going to skip that. I'm just going to go to this guy. But does it scale? You're probably asking this question. Does this scale? And to that, I would just say GraphQL subscriptions are very ready for production, and they're very scalable if you scale them. In the example that I showed you before with Apollo server, this is a simple pub sub example where it would work only on one instance. Now we have built demos where we've pounded that one instance and it works really well. And that's just using that. But if you want to ensure that your subscriptions work across instances all over the place, you could check out Redis with Apollo server. You could check out Hasura, AWS AppSync, and some other tools as well. So if I leave you with anything, it's that subscriptions are ready for prime time. They're ready for real time. And I want to thank you all so much for having me today. It's been an absolute pleasure. And I'm happy to answer any questions here, or always feel free to get in touch with me online. Thanks so much.
Thank you so much, Eve. That was awesome. I'm personally just starting to dive into GraphQL beyond Gatsby, so I feel like this was just a great explanation and sort of crash course for me. I feel like I actually sort of know what's going on.
That's my goal, to have people sort of know what's going on.
Yeah, no, I mean, it was clearly presented. If anything didn't penetrate, the fault is on this end. All right, let's see if we have any questions coming in the chat. But I did want to ask, so I'm doing a book club on how to GraphQL. And one of the topics of discussion that came up was sort of like, hey, this GraphQL space feels sort of, there's like a lot of marketing going on and a lot of hype, but there's like a couple different tools that everyone's talking about, but like, where do you choose? Like, I've heard Apollo, I've heard Prisma, I've heard Urkel. Like, where do you sort of start if you're new to GraphQL and sifting through this? Would you recommend people start with Apollo?
What I'd recommend is starting, if you can, with the query language and the schema language itself. Okay. So no matter what you build with GraphQL, you're going to be using the query language. You're going to be looking at some sort of a screen that looks like our playground screen that you saw before. A good way to play around with that is the GitHub GraphQL API Explorer. I should have a short link for that. But this is kind of one of the first examples of a big API, a big company making a big bet on GraphQL. So you don't have to make any decisions to get data from the GraphQL API. It's built. And if you think about REST APIs that exist out there, I think more and more we're going to see screens that look like this. And no matter who you are on the team, no matter if you're a project manager or designer or front end or back end developer, having the knowledge of writing a query is going to serve you really well in the next 5 to 10 years, I think. And that's a really good place to start, because no matter what avenue you go down, you'll be using that in literally everything you do. So I would start there. And then as far as the whole ecosystem of tools, you mentioned howtographql.com. If people want to really like a website, you should go to that website because it really has great, I'll bring it up since my screen is still up. It's a free resource that you can use to kind of go down some of these different paths. If you're a front-end developer, maybe you want to take kind of the front-end track or the back-end track. And yeah, it is tricky to try to choose from those tools of the ecosystem, but starting with a query language will mean that you can get kind of ramped up in a way that doesn't overwhelm you with tech decisions that sometimes you can get into.
You can get to the learning instead of the tooling and decision making around that stuff.
For sure, yeah. Because I feel like sometimes with too many options with tooling, it sometimes feels like, oh no, I'm never going to actually build anything because I'm just going to stress out about if I'm choosing the right thing. I think, yeah, you'll probably be in situations where there's mass disagreement on which tools to use too. So yeah, starting with the basics is always a good idea.
I think the disagreements just come in sort of with the territory, right?
Just in general. Yeah. Just people like fighting.
But for like what you're talking about with the query language itself and schemas and types, I would imagine your book is a great place to start with that.
Yeah, definitely buy my book.
Yeah, let's pull that up real quick. I think people are in the chat are legit interested. So
I should know this, but I have a link for Safari or O'Reilly.com it is now. So they have a try now thing that will give you, I believe, 7 days. I have a link that you can use for 30 days if you'd like to check that out. I'm kind of bad at asking people to buy stuff that I make, but you can totally buy it too. You can find it on Amazon or other book places, but it's just called Learning GraphQL, and it's an O'Reilly book.
Awesome.
People are saying, show the book.
Yeah,
show
the book. I see 1,000% interested. I see show the book.
Okay, cool.
I see so good.
Yeah, so Learning GraphQL is what it's called. You can check that out on O'Reilly.com, and that'll give you all the information about where to buy it and all those good things.
Awesome. I'll drop the link in our Discord community for everyone who's in stream, just to make sure they have that. But I do have some questions coming in. Emily, our previous speaker, was asking, what are some common use cases for subscriptions outside of what you just showed us? And she said, are there more typical uses for subscriptions specifically?
Yeah, I would say when you reach for a subscription, you're probably you want to think about those actions, those parts of your application where real-time data is really important. So I mentioned Ticketmaster before, like tickets is a big one, right? Because if it sells out, you want to let everybody know who is logged into that same socket or looking at that same event so they can make sure to, I guess, log off, or they'll know, I guess, in real time. That gets to examples like the real-time chat, as someone mentioned, the stock ticker. Yeah, I feel like a lot of different like chat applications are using it. Like I mentioned, the Facebook stuff where you see things happening in real time for liking a post or things like that. I wouldn't try to use subscriptions for absolutely everything because there is a little bit of setup that's required for scaling those out. However, people have found a lot of benefits using that, and I see them used more and more. Zillow's using them for their chat and others as well.
Yeah, and I guess that question also brings up sort of what you were talking about near the end. You had those two, the charts where, what is it, the query and the mutations run through HTTP, whereas the subscriptions run through WebSockets. Could you give us like a TLDR, if you could, on the difference between those two for anybody in the chat who's not aware?
Totally. So let's see, our voting application here. So let me take a step back. So in the center of our screen here, there's a URL for the GraphQL endpoint. So with GraphQL, there's a single endpoint, and we make a request to that endpoint. So why do we make the request to that endpoint? It's just an HTTP request where we're asking for some data from this particular URL. So with REST and with other transports or with other API languages, you'll see HTTP requests used a lot for transporting data around the internet. And this works really well for queries and for mutations because we're asking for something and then we're getting something back.
Right.
Now with subscriptions, it's a little bit different because of this real-time nature of things, right? So every time I issue this subscription, we're listening. We're not saying, hey, call me back when you have some data, and then hanging up, and then you get a call back with the data. Instead, we're like, I'm gonna wait until you have data. Just let me know when you got something, hit me up.
We're sort of lurking.
I'm just gonna lurk here. Just hit me up when you have some data. I'll just chill here. So the way that the subscription works is it's going to hang around and wait, and it's going to send that back. Now with HTTP, it's not that request and response thing anymore. So we needed a different type of transport to make that work. WebSockets are part of the browser, and they're supported by the browser, I should say, and we see them in a lot of Node applications. So Apollo has built this into their server as the way of transporting that data. So basically the way that it works on the server is we literally look at this query. We look at this subscription. If it says subscription at the beginning, send it over WebSocket. If not, send it over HTTP.
Got it. Yeah, and we have a follow-up question on that actually is, because the connection, I guess, is staying open. Someone was asking, is there a performance hit for subscriptions, or is there like a limit for how long it'll listen before it says, hey, I don't have any data coming in, I guess I can stop listening?
Yes. So all of that depends on where your data is. So a lot of the questions related to subscriptions are like, how does this scale? How do I set this up for real? How does all of this work? A lot of the tools that support GraphQL subscriptions will set up defaults for that. So timeouts and things like that can be adjusted to enhance performance. That's why you probably don't want to make every single query a subscription. You want to save those for the real time stuff. You know what I'm saying? So a voting app is a good example, or a chat is a good example where we really want to make sure that the users are finding out about the latest data as soon as possible. But yeah, that really varies based on your stack. But the whole idea of the subscription is baked into the language itself, and then it's kind of up to you to later on, choose the tool to implement it. I'm sorry.
So you can't, it's like if you're having an issue, it's not like GraphQL is the one to blame. It's usually the where you're getting your data source and that server and how that's configured. That's sort of where the blame would lie, I guess you could say, if you want to point fingers.
Correct. Don't blame GraphQL, blame everyone else. So
yeah, hey, we saw that Philadelphia does that, so that's totally fine.
Perfect.
A couple people mentioning in the chat that they saw you on the React podcast a week or so ago. So that's cool.
Oh, that's nice.
People are familiar and have heard you speak before. And then we have a question. Can you speak on the parent positional argument for resolvers? What are some of the use cases?
Sure. Let's see how I can talk about that without talking for 4 hours. This is what I always do when I'm teaching class. I say right here when I type parent, I say to do, yell at Eve to explain parent. And then I move on because we always talk about args first. But the real reason for this argument here is you'll see it a lot of times with, I realized a faster way to do this is to show you a finished example. So an example of this is here in this ski resort API. So what we have going on in this ski resort API, basically we use this parent object to look up data a lot of times. So for example, we have in this API, we have a lift and we have a trail. Both of those are the types that are part of the ski resort. Our data source for the lift doesn't have a field for trail access on it, but that's okay. It doesn't have to because we can actually build it. So let me show you an example over here. So let's say I created a, let's say I added a field to results called ID. And as we know, we don't have an ID. We just have a number, right? For Philly and everyone. So what I can do here is I can create, let's see, a resolver called results. And here we're going to say parents. And then we'll say something. How about that? How's that looking? Really cool.
Perfect.
So good. I'm so quick.
Hey, naming things are hard. So I mean,
I'm very quick.
This is a realistic example.
This is not a good space to be in. I'm in hell. So what I'm doing here is wrong and very clowny because I'm trying to thing and done. Yeah. So I'm going to go back here. So for example, let's say we wanted to on our lift data, right? And I'll show you some of this data. This is our cool little database. So for example, we have this name, capacity, status, night, whatever. If we wanted to use that parent argument, the way we would do it is not in the bad way that I did it before, but in a better way. And that's to say like URL. Each lift will have a unique URL, but our data didn't have that, right?
Yeah.
But here's what we can do. We can go down to our resolver, and because we're thinking clearly now, we're going to say lift, and then we're going to add that URL field. So this is just a function, right, that returns some data. It's not going to come from the database because it doesn't exist. But I can say every time a person asks for this URL field, I want to return some sort of string /lifts.html. That's sort of cool. But what would be cooler is if we could, for each one of these lifts, we could say we could grab that parent object and we could change this to a template string. And then we'd say something like parent.id.html.
Got it.
So now that'll build that for us. Fake ski resort.com/ you know what I mean?
Yeah.
So that's how we parse that information. The reason I skip over it all the time is because the position of these arguments is important. So like the arguments always come second. That's the user input. The context always comes third. But this parent thing is useful in situations like this, but also when you connect different data types. What a long walk to get to our destination, but we're here. We arrived.
That's a good explanation. I think that's a pretty good example of exactly what you're talking about here. I think that answers the question in chat. I'm sure it does.
Sweet.
The only other question I have before I let you go is someone said, and I'm going to take a guess at what the answer is to this, and you can tell me if I'm wrong. But someone said, I'm wondering if a subscription could send data without the mutation firing. But my understanding is that a subscription only sends data when a mutation happens that it's listening for. Is that the case?
Yeah. I think it's possible that you could set up your server to handle it differently, but most everyone does work like that. The mutation triggers the event, and then the subscription listens for that event. And then if anything changes, the subscription captures it. So, yeah.
And would there be any use case or any example that you could think of that a subscription would send data without a mutation firing? It sounds like it's possible, but I don't know if it's like, it may be possible, but not practical. Is that sort of the case here?
Yeah, it's kind of like the difference between listening for a data change and listening for a specific event. So there's this idea of a live query that you could get into if you wanted me to talk for a lot longer. But I think for the most part, we always are triggering those events with mutations. So it's very possible to do things differently though, because as I said, GraphQL is just a spec and you can do all sorts of wild stuff with it. I said there's HTTP and WebSockets for transport. That's like kind of arbitrary because you can send it over any sort of transport. So there are no rules in the land of GraphQL, and we are just going to do what we want because we're in charge.
Awesome. Bringing it full circle with that whole idea that GraphQL is just a spec. I love that. Yeah, thank you so much.
No parents, no rules, no problem.
Yeah.
Thanks, Jason.
Thank you so much for joining us. I really appreciate that. And of course, any questions that come in chat afterwards or through Discord, we'll relay to you, and we'll drop all your resource links in our Discord as well. So thank you so much. I'm gonna mute you now real quick. I'm gonna switch back over to myself.